My name is Burt Thomas. I'm a geochemist at the National Energy Technology Laboratory, and I love rocks. I grew up in St. Louis, Missouri, which is well regarded as having no mountains. I've really always loved rocks, so geology was really very exciting to me as a kid. So I remember going on a driving road trip with my mom and my sister to Colorado. And I remember the first time I saw the Rocky Mountains and being just completely floored. Like, it wasn't even possible. I mean, I'd heard of mountains, but when you actually saw the mountains, I'm pretty sure that I became a geologist when I saw the Rocky Mountains for the first time. For me now, being a geologist, though, isn't just about the rocks. It's as much about the oceans, and it is also about the deep sediments in the subsurface. One of the problems with rocks that are deep underground and understanding how they work is that it's really hard to perform experiments down there. I spend most of my days trying to simulate the environment in the deep subsurface in this laboratory so that we can understand how fluids and rocks and engineered materials like wells react. Every single one of these pieces of equipment is designed to simulate a different environment. In some cases, we need vessels that have a fixed volume that allow us to prescribe the conditions of pressure and temperature in the subsurface. And in other cases, we want to be able to push fluids through a material like a sandstone that might be part of an oil field reservoir, for instance, or a cement that might be part of the wellbore that prevents oil and gas from leaking out of the wellbore and makes sure that it comes to pipes at the surface. I think the more creative you are, the more successful you'll be as a scientist. Because most of the problems that we run into as scientists are only solved by thinking outside the box, by understanding what else could explain the results. So in many cases, we don't know what the right answer is. My favorite part of my job is when we are surprised by a result. And that leads to a whole set of new questions that lead to a whole set of new possible experiments that we can follow.